Hello, my name is Edward C. James, and I'm a student at Dakota State University. And this is going to be the solution to the student lab for the 725 on my project on networking. So basically, what I had asked previously you guys to do was uh, to utilize Wireshark to inspect some packets that were going to be sent from one machine to another. And in this case, you have the flexibility to do it from two different Linux machines or Windows and a Linux. And on one machine, you were to collect packets by utilizing Wireshark, and in the other machine, you were gonna be sending the protocol packets and experiment with that. It doesn't matter how you do it. I prefer to do it from a Windows machine. This is a Windows 7 machine, and this is my backtrack machine. Now you would think that you are going to be doing all the um, that you're going to be doing all the sending all the packets and from your backtrack to your Windows, but I'm actually doing it and collecting it from uh, via Wireshark on Windows, but I'm doing it the other way. I mean, you can do it either way. You can install Wireshark on your Windows machine and send all the packets from your backtrack, or vice versa. And that's exactly how I decided to do it. How I decided to do it is that all packets will be sent from my Windows 7 machine to my backtrack, and now I'm gonna demonstrate basically how it's done. Let's see. Let me close out. I will clear. I like to have a clear screen. So basically, I'm gonna show the IP address that I have on this is with the ipconfig, and that's what I have. ipconfig. My IP address is 192.168.184.143 with a mask address of 255.255.255, which means it's a Class B address, and it's since it starts at 192.168, that establishes that it is a Class C private IP address, like I mentioned before on the theory portion of it. Now, one important thing to do before starting Wireshark is that you put your card on a promiscuous mode. The reason for that is so that every packet that comes in, you can sniff it and collect it. So how you do that is that you do fconfig, then you select the Ethernet card. In this case is 0, and as it's indicated right here, and it's giving you the MAC address in this portion right here, and it's giving you the internet IP address right here with the subnet mask right over here. So what we do is that we put it in promiscuous mode. There it is. Okay, now that it's in promiscuous mode. Like I mentioned, you guys, what I have intended to do is that we send different types of packets, which is ICMP, and we're gonna do it through ping and trace route. We're also gonna be doing sending telnet packets, and in order to send telnets, I have to have telnet um, configured here. And this is and in order to configure, I have to install it, of course, with the apt get install telnet d. I already have it, so it just tells me that it's already there or whatever. But normally it decompresses it and installs it, and then you have to turn it on as well, because it's not on by default. And you do it by going to this folder, the D, open, that was B, that one right there does the correct one, and you do restart so that it can be reloaded. There it is, restarting internet servers, super server init D. That's for the telnet. And now also we gotta, like I said, we're gonna be sending FTP packets as well, so it's important to install VSFTPD. Oops, I think I got it. Oh, it's V as in Victor, no F SFTP. So VSFTP. Okay, maybe I have it wrong. Let's see. Oh, okay. So install has two L's and I'm putting just one. It's sensitive. Okay, couldn't find package VSFTP, but it's because it's already been installed. I believe VSF TPD. Yeah, I already have it installed. So in my case, mine failed, but that's quite alright. Oh, okay, and I did it wrong. VSF TPD. There it is. Yeah. Of course, it says that nothing has been upgraded or anything because I already have it. So of course it's not gonna install. But when you don't have it, all the installation will go through. And move this out of the way. Okay, now also it's important that we install SSH. It's called the Open SSH server. It's going to be to do an SSH connection. Let's see, apt get install with two L's, of course. Open SSH server. I think that's what it's called. Let me double check. Yeah, that's what it should be called. Now go that. You see, it does the same thing because I already have it preloaded. I tested it before starting this video to make sure everything works the way it's supposed to. And now, and that's that. So everything that we need has been installed already. So what we're gonna do, we're gonna run Wireshark. And since we put it in promiscuous mode, it should work fine with no problem at all. So I do Wireshark. That's the command to start Wireshark. There it is. It opens up. This is the running users root and group root. This could be dangerous. It warns you because I'm logged in as the root, and it tells you that might not be a good idea to run things as root. But in this case, it's just for the purpose of running out just for this lab, which is quite alright. It's already picking up packets. They're all as you can see, it's showing the MAC address as a source. So they're all been established from they're all layer 2 packets that are being circulating, which is fine. But all the packets that we're going to be sending are going to be layer 3 networking packets. So let's jump on our Windows machine, and it's actually, oops, the wrong one. So I'll go to Windows 7. There it is. So the very first one that we said we were going to do, it's a ping. So we do ping 192.168.184.143. So it's pinging it, it's replying, and then we also do we're gonna do a trace route. In Windows it's called tracer, and just abbreviated like that, and it'll show the hops of over the network, which there should be only one. It's linked. The machines are linked, so yeah, it'll complete like almost right away. There won't be a whole lot to it. And then also we're supposed to telnet to it, so we'll telnet. Telnet 192.168.184.143. It'll ask us for the login. I think the root is not meant to be logged in as remotely, so it's gonna fail, which is quite alright. We'll try that, and we'll try it again just so that we can generate more packets. And we'll try one last time. It'll fail, but it's alright. It'll still generate the packets, which is quite alright. And I'll just break the connection. There it is. It has been lost or removed. So now I'll FTP 192.168.184.143, and we'll FTP into it. I'll put the username. It'll fail too because it's not. It doesn't have a user that can be logged in as remotely, so it's quite alright. My intentions are just to run the packet. It'll fail. That's a given. And now I just close FTP with the by command. Clear the screen again. I always like to have a clear screen. That makes things a little bit easier for me. Now we can SSH. I don't have SSH installed on this computer, so we can take another route. We can telnet 192.168.184.143. We can telnet on port 22, which is the port for telnet. I mean not for telnet, but for SSH. And it won't even generate. It'll just send the packets. That's the only thing it's gonna do. It's not gonna try to log in. So you get a blinking cursor. That's the indicator that a packet has been generated for it. We close the thing. Enter. Connection has been lost. And we'll do another one. We'll actually do one on port 80. I don't have port 80 open, but I'm gonna see if it generates a nope. Connection failed. It's not even gonna do it, so I won't even bother with it. That's fine. We exit out of it, and now what I'm gonna do, I'm gonna go ahead and run a port scan on it. It's 192. That one's okay. Of course, I gotta put nmap, and I gotta spell it correctly. Nmap. We'll do a simple one. Sin scan. Uh, 192. Dot 168. Dot 184. Dot 143, and run it. I'm using ZenMap, which is a graphical user interface that's like so script kiddie like, but it's alright. It just serves the purpose of what I'm trying to do. I'm not trying to impress or anything. And now for this right here, we can stop it. Let's see, this one is to stop, isn't it? Yeah, stop running live capture. Okay, so that's it. I'm done running them now. So it's time to inspect the packets. There's quite a handful of them. So you can see these are all the ones that were on the layer 2, but as we progress, we can see the ones that were on that were run on layer 3 that came from for my other machines, my Windows machine, which is that 141, and I'll prove it. Let's see. Epic config. Yeah, I always confuse them. This is what I have. The 151 is showing us the 151, and here it shows us that 141. That's kind of weird. um, I don't understand why it's showing. It's weird because it's showing them like let me try again. It should be that 141. IP config. Let's see. Something really strange that I've noticed is that I'm showing IP config that 151, but in reality, let's see this one right here. I'll open another window to show you the IF config. It comes to 143. So basically, from a machine, it should be the 141, not the 151. That's what it was a minute ago. Anyways, whatever. I'll just go ahead and go through them. Let me go through the ICMP packets. See, that's the 141 is the Windows machine. I think I put like some type of what is it called? From my last class, I think I put like a IP spoofing tool or something, but it doesn't matter. I'll just go through the packets and see. This is the ping from my Windows machine, and let me see. Let me see if it matches. Let's see, what is it? Trying to look for the MAC address. Locate way. Showing a 0. So it's a whole lot of mess here on VMware. But yeah, what matters is that this right here is supposed to be the MAC address of the computer, and this is where it's going, which is my Linux machine. This is the ping request, as you can see, and this will be the ping reply. Now let's keep going. There's more ICMP. Yeah, these are all the pings. See if I can filter. Okay, no, it needs to be a header field. Okay. TCP. There's a telnet connection from this is the response that this machine gave to the Windows machine. And here's the telnet again. It's basically the telnet connections right here that have been established or that attempted to be established. Let's see. So the telnet that was tried, and the length of the packet, and the info on it. So the telnet attempts. Let's see. Try more than one. So it generates quite a bit of packets on, for that matter. Let's see. See if I can filter FTP, I'm not sure. There it is. There are all the FTPs right here. The FTP processor, even the root right here, and the password right here on the clear. So as you can see, it captures the username and password and how it quit, and even the goodbye command that was sent to it. That's the FTP right there. And I was gonna show you as well as the, yeah, these are right here. This is the port scan being done right here. This is what Nmap generates when it tries to that's where you see the IMAP and all the connections right here. It's Nmap trying to, yeah, you see capture the bits that the 60 bytes that were sent. This is right here, everything that's done. You see the sync, acknowledgement on SSH, and you tried every port that it could in order to establish what ports were open. This is right here. This is Nmap at its best, working right here, trying to decipher what ports are opened and what ports are closed. Yeah, Wireshark is really useful. It reveals a lot of information on for this matter. It's an excellent tool. I'm not that great at it, but at a glance, I can just tell you that uh, it gives you a lot of information on this matter, as far as what packets have been sent and received. If you take the Wireshark class, it can be incredible. What you can learn, it can be quite impressive, and it even goes as far as doing networking forensics. So that might be one thing that you guys want to get into, trying to find a little more. But this has been it. And before so I close Wireshark. I don't save the I don't intend to save the I intend to quit without saving. That's fine. So but also I intend to let's see, stop the services, because that can be a potential opening for a hacker to always shut down your services when you're not using them. So that's the telnet service. And FTP, I don't even think that let's see, oh yeah, I gotta remove it from promiscuous mode as well. It's not promiscuous anymore. No, that one started automatically, so it doesn't matter. So the SSH and the FTP are fine. They don't have to be stopped. They stopped automatically, and that's about it. That has been my presentation. I really I'd like to thank you for viewing, and I hope that this lab was as simple as I thought it was. You guys have a great day.